So the demo we're going to look at today is looking at LinkedIn data from the perspective of recruiters. So we know that recruiters are heavy users of Boolean syntax, and the AndOR components that I'm developing can be assembled into applications that help people write Boolean syntax more transparently and suggest useful terms to them. So this is a prototype built on some Kaggle data. So I found a LinkedIn data set on Kaggle, which is quite small really. It's only about 1,200 resumes, so it's only about 1.57 meg zipped, but it includes sort of names, locations, categories, skills, and those kinds of things that we would expect to see on a resume. So this is an illustration of the sort of system that you can build, albeit at the moment just done with a small amount of data in there. So the suggestions that come up aren't quite as good as what we would expect from a larger data set. So I have an example of that coming up afterwards. So let's kick off with a search for somebody working in public relations. So the resumes here have the name, the current position, location, a set of skills, and a description and some experience. So we can search for free text. So I can just do a regular keyword search and search for PR or public relations. And we can see that there are a number of people who match that. So it's only a handful of people, actually. It's about 10 people out of the 1,200 that we have. And we can see that the category that they put themselves into is public relations. So if we look at the breakdown of the categories field, we can see that all 10 of these people belong in public relations. So maybe there are some resumes out there that didn't use the word PR in the text anywhere, but they put themselves in the category public relations. So that would be another way of describing yourself as a PR professional of some kind. So what we can do is we can pick up public relations and we can drag and drop it as an OR. So now we've just increased our set of matches now to 49. So people who don't mention the characters P and R in the text, but actually put themselves in the category of public relations. So we're hopefully sort of improving our query as we go along. The actual text syntax of the query is shown here, using ands and ors and brackets and all that kind of hairy stuff. But it's often a lot better to look at information in the graphical form. You can sort of see the breakdown of how many matches are coming in from each of the clauses that you're using. You can edit them and change various different properties and things. So what we might want to do now is focus in on the skills. So a large part of what we tend to do when we construct queries is look at suggestions that are coming out of the data. So out of these 49 matches, this tool's done an analysis of which skills are commonly associated with these people, but less so with other people who aren't in public relations. So we're ignoring the fact that these people might know how to use Microsoft Excel and things like that, which are relatively boring and across the board, and focusing on the things that are peculiar to the public relations field. So we get things like media relations, corporate communications. And what we're seeing with these bar charts is the blue is essentially all of the people that we've matched already, and the green is the additional people that we would match if we were to add these in as an OR clause. If we were to expand our query with media relations as opposed to just public relations, let's do that now. I can drag it up and put it into an OR. So we should see our number of matches go up from 49 to however many were hovering there in the green part of that bar. So there we go, we've got 53 matches now. So obviously some things are quite broad, so marketing in general. There's a lot of people who have profess to have marketing skills in public relations, but there's probably a lot of people in marketing who don't have any public relations skills at all, so it's probably not something that I want to add to my query. But let's say for the sake of argument that I was interested in handling a crisis. I'm after a crisis communications expert. So I could pick that up. And maybe another aspect to this might be reputation management. So maybe that's something I'm concerned about. So I want to get some skills in that area. So if I drag my query and make that an AND, I'm now filtering down my set of PR people to the ones that have special expertise in crisis communication or reputation management. So we can see that in this sort of filter here. We matched 53 people in PR, and then we matched 14 people with specialisms in crisis management. And as a result, we also got some sort of more refined set of skills that are associated with this set of users, these 14 matches. So crisis management is listed here as well. So I could pick that up and add that in as another OR here to sort of expand the set of results that I have. So let me just pop that there in the OR list for crisis management. So having given some sort of shape to these sets of skills, you can kind of fold them up, you can give them labels and all that kind of stuff. We might now focus in on location and see where we can find these people. So we have a set of locations here. We can pick up, let's say we're interested in New Delhi, South Delhi. So again, we can pick those up and drop them in as an AND. So a choice of New Delhi or South Delhi, but that's an ANDed set of results to the ones that we already have. So we're down to four matches now. And of course we can sort of go in and perhaps go over to LinkedIn and have a look at the individual profiles of those people. So that's an example which is showing you how to refine and craft queries using Boolean logic. We can also do excludes as well. So maybe if you worked your way through the 4 people who are in the Delhi area, then what you might want to do is say, well, exclude those. I've already ruled those out of my inquiries. And we're now back to looking further afield and looking at other locations where we might choose to drill in on a different location now and see who's there. So that's how the Boolean logic works here. I'll just give you another example with a different data set, which is quite a bit larger. So rather than 1,200 documents, we're going to have a look at 23 million documents here. And this is every question that's ever been asked on the programmer's website, Stack Overflow. So it's a very popular website. If you have a technical problem, you might ask a question like this. So let's go and have a look at this particular question. This was asked by a person, how do I do X? And they were looking for an answer. And then somebody answered, and it's got a check mark here. So this was accepted as a legitimate answer as opposed to something from ChatGPT or something like that. So that's why we have a answered by. Now all this is useful information. We've got dates as well, when were the questions asked and all those kinds of things. Let's search for Elasticsearch. So that's the tool that I'm most familiar with. If we search for Elasticsearch, then we can see when those questions were being asked. We can also see a lot of related tags. So Nest is a tool used by C# programmers to talk to Elasticsearch. Kibana is a visualization tool. Logstash is a tool for getting data into Elasticsearch. And the Elastic Stack is collectively all these things together. So I might want to take these 4 clauses and add them in. So this ability to expand your queries beyond, just your basic initial search term is useful for people who might not be specialists in Elasticsearch or any of those kinds of things. They can see immediately the set of terms that are commonly used by people and that would be useful to expand their query. For example, elk stack is what they used to call the Elastic Stack. So now what we might want to know is who are the experts who are answering all these questions related to this technology stack. So if we go into problem solvers, we can see here there's a chap called Val who's pretty prolific when it comes to answering questions. And we can pick up all these other people. Ruscam works for Elastic, as does Andre. So a few of these guys I used to work with. So let's pick them up as individuals. And what I want to do is see which one of these are still active on Stack Overflow. So the way we might do that is to pick up the selection of people here and drag them into our date visualization, and then view them as sort of individual characters or swim lanes over time. So we can see Igor here, for example, was one of the very early Elasticsearch adopters and was very active in the Stack Overflow community before he became part of Elastic and was busy working on Elastic. Whereas Val here has been a very active member of the community, especially during sort of around 2016, but even so up until today. So, we might want to focus in on Val, add him as an and to our query, and we can then sort by date and have a look at what the most recent thing he's been up to here. And we can also go in and have a look at his profile. So let's dip over to Stack Overflow. There's Val, there's his LinkedIn profile. So it's very useful as a tool here to be told about any given technology, what the related tags are, who the active people are who are working in that area, and construct these queries. And it's the sort of thing that we could do much more effectively given sort of a richer data set on the profile data as well. So if you have any of that sort of data, if you're interested in putting something together using these components and having this style of interface working on your data, then reach out and get in touch.